Okay, on the previous video, we went through the process of calculating the eigenvalues for uh, this matrix. Okay, so now that we have our eigenvalues, we are going to find our eigenvectors. So what we're going to do is we're going to plug in each eigenvalue to the new matrix, or to get a new matrix. Okay, so, and the solution of the equations, okay, and we're going to end up with a system of equations. Okay, and the solution to this equation gives us the form of an eigenvector. Okay, and any scalar multiple of the answer is also an eigenvector. So let's start this here. So we've got A minus lambda I Okay, and so now we're going to use the first one here with our eigenvalue of 3. Okay, so now I can say A, which is 1, 1, 4, 1, minus 3, and I'm not going to write lambda, I'm going to write 3. Instead of writing that, I'm writing 3. Okay, right? And then my identity matrix is 1, 0, 0, 1. Okay, and instead of writing this matrix, I'm going to call it x, y. Okay, it's going to give me the ending point of my vector. And 0, I'm just going to write that as a column matrix 0, 0. It's a 0 matrix. Okay, let's put that in parentheses because that's in parentheses. Okay, so let's multiply the 3 through. So I've got 1, 1, 4, 1, minus 3, 0, 0, 3. Okay, so we got matrix subtraction. Let's do that. So 1 minus 3 gives me negative 2. 1 minus 0 is just 1. 4 minus 0 is 4. And 1 minus 3 is negative 2. Okay. X, y, and equals 0, 0. Now, at this point, Professor Dave solves this in a completely different way, and he'll get the same answer, but I'm not going to talk about reduced row echelon form for solving the matrices. And what we're going to do is we're going to look at each row. I'm going to, when I multiply this times this, I can get negative 2 times x, which gives me negative 2x. I get 1 times y, which gives me y, and that's going to be equal to 0. And then I could do the second row. I've got 4 times x, and then negative 2 times y equals 0. Now, you're going to find out that these are actually the same equation if you've done this correctly. Because if I multiplied this top row by negative 2, then you would see that these would be the same. So I'm just going to take this row here. It doesn't matter. So I've got I've got negative 2x plus y equals 0. Okay, so we're going to use this guy here. So if I'm going to choose, let's just add 2x on both sides. So I get y equals 2x. Okay, so I just want to simplify this so I can get a final matrix. So I'm just going to choose, let's say if I make x equal to 1, then I would have y equals 2 times 1, right? So that means y equals 2. So if I've got a value of 1 for x and a value of 2 for y, then my result vector is going to be 1, 2. And this is our eigenvector. So and what do I write for each one? So this is our eigenvector. That corresponds to lambda equals 3. Okay, so if I'm dealing with a scalar of 3, then my eigenvector, this is my eigenvector. And I can use any form of this. Okay, so what I mean by any form of that, it could be in any direction. I could have any scalar times it, and it will be an eigenvector. The definition of an eigenvector, as you might recall, is that an that's an eigenvalue. An eigenvector has to be going in the same direction as the other vector. Okay, so now let's find the eigenvector when lambda equals -1. So okay, so we're going to use lambda equals -1. So I'm going to replace lambda with -1. And a, we know, is 1, 1, 4, 1. Minus, okay, -1 times I. So I'm going to have -1, 0, 0, -1. I've multiplied my identity matrix times my lambda there to get that. I'm going to write x and y. It's a funny looking y. And my 0 matrix, I'm going to write 0, 0. Okay, so now let's do matrix subtraction. Okay, so so if I do matrix subtraction, I'm going to have 1 minus -1, which is going to give me 2, 1 minus 0, which is 1, 4 minus 0, which is 4, and 1 minus -1 is going to give me 2. X and y equals our 0 matrix. Okay, so just like before, I can take this row times this column. I will get 2 times x plus 1 times y, and that should be equal to 0. And I could do the same thing with the other row. 4 times x plus 2 times y equals 0. And just like before, these equations are one and the same. So using this equation here, I'm going to subtract 2x on both sides, so y equals -2x. And now we've got a relationship between x and y. So just to make things easy, if I choose x to be equal to 1, then y is going to be equal to negative 2 times 1. So y equals negative 2. And now I've got what I need for my eigenvector. My eigenvector is going to be equal to 1, negative 2. That is my eigenvector. And, okay, I hope that's helpful. For the next few problems, I'm going to just walk you through the steps, and I'm not going to, because otherwise this will take forever. Okay, so find the eigenvalues and the corresponding eigenvectors. Okay, so just like before, we're going to use this to find our eigenvalue first. Okay, so my matrix A is 0, 3, 1, negative 2. And we've got minus lambda times our identity, which is lambda 0, 0, lambda. And we do matrix subtraction, so 0 minus lambda gives me negative lambda. 3 minus 0 gives me 3. 1 minus 0 gives me 1. Negative 2 minus lambda gives me negative 2 lambda. So we've got this matrix. Should put that in parentheses. Times vector x equals 0. Okay, so now we're going to find the determinant of this matrix and make it equal to 0 in order to get our characteristic equation or characteristic polynomial. So I'm going to do negative lambda times negative 2 negative lambda minus 1 times 3. And then I could do distributive property with this negative lambda. So negative lambda times negative 2 is going to give me positive 2 lambda. Negative lambda times negative lambda is going to give me positive lambda squared. And negative 1 times 3 is going to give me minus 3. And so here is my characteristic polynomial. And then I look at this and I say, oh, I can factor this out. And I can write this as lambda minus 1 times lambda plus 3. These have to be opposite signs. And since this is plus 2, this needs to be positive, that one negative. Okay, so now I factored it out. So now I know my eigenvalues are 1 and negative 3. Okay, so these are my eigenvalues. Okay, so piece of paper. Okay, so let's just find the eigenvectors one at a time. So using lambda equal to 1, I've got this formula here, and I'm going to turn lambda into, I'm going to replace that with 1. So I'm going to have my original matrix 0, 3, 1, negative 2 minus, and now I'm making lambda equal to 1. And then I'm writing my vector as xy, and I'm writing this equals the 0 matrix. Okay, so now this is just simple matrix subtraction. 0 minus 1 is going to give me negative 1. 3 minus 0 is going to give me 3. 1 minus 0 gives me, what did I do? 1 minus 0 should give me 1. And negative 2 minus 1 should give me negative 3. Glad I got that mistake. So just like before, I could multiply negative 1 times x is going to give me negative x. 3 times y is going to give me 3y, and it equals 0. And so using this relationship here, I can add x on both sides, and I get 3y equals x. So then if I choose y to be equal to 1, then x is going to be 3 times 1, which is going to give me 3. Okay, so now I know my eigenvector is 3 and 1. Okay, and so we can say the eigenvector for with the eigenvalue of 1. This is an eigenvector for an eigenvalue of 1. Any vector in this form is an eigenvector that corresponds with lambda equals 1. Okay, you might want to hit pause if you need to look at this, or replay if you need to hear it again. Okay, now I need to find the other eigenvector. We're going to use lambda equals -3. Okay, so I'm replacing lambda with -3. And I'm going to say, okay, so my matrix A is 0, 3, 1, -2. And minus, because this is minus, right? And we're plugging in -3. This should be a -3. My gosh. Okay. So I'm plugging in -3 in place of lambda there. And so now I'm going to do simple subtraction. 0, and we get this. 0 minus -3 gives me 3. 3 minus 0 is going to give that. 1 minus 0 is going to give me 1. -2 minus -3, so that's -2 plus 3, that's going to give me 1. Okay, you can tell I made some mistakes with addition and subtraction. Good thing I fixed it before this video. Okay, so now I have 3x plus 3y is equal to 0. So we know that if I subtract 3x on both sides, I know that when x is 1, y is going to be -1. So my eigenvector is going to be 1, -1. For any form of the eigenvector that corresponds with an eigenvalue of -3. Okay. For the next problems, I'm just going to show the work, and you can check your answers. You may want to hit pause. Okay, so for the next one, I'm going to show my steps, and you may want to hit pause. Okay. Here's the first steps for finding the eigenvector. You may want to hit pause. Okay, the second steps for finding the eigenvector now. You may want to copy this and hit pause, or try it on your own first. Hit pause. Okay, the next one, like I said, try it on your own first, and then hit pause to check your work. And then the second half is finding the eigenvectors, and here you go. I hope you found this helpful, and I hope everybody had a good weekend.